Welcome. Today we are speaking with Mariano Fernández, Staff Project Manager for CI/CD and Compute at Vercel. For the last decades, backend have been optimized for speed. But in the era of LLM, the paradigm is shifting. Slower is better. It's proven that the longer LLMs think, the better are the results. And in the context of serverless, it means that while your backend is waiting for an answer from the LLM, you are paying for idle time, which can result in huge bills. That's why Vercel built Fluid. In this episode, we'll discuss the technical implementation of Fluid, some of this built-in reliability mechanism, what it means for developers, and the future for our industry. Let's jump in. So Mariano, can you share about the problems that come with, I would say, traditional serverless when companies are running AI workloads?
Yeah, sure. I think the main issue that we are facing nowadays is that the workloads have changed. We are used to this kind of workloads that you will run on your serverless functions that are just, quick queries to database, quick queries to a backend, something like that. We have optimized around that about quick response times. But when we are moving into the AI world, into the AI workloads, now we have functions that will take a long time to respond. And sometimes you want them to take a long time. You want your agents to be able to play. You want your agents to be able to reason. You have those long AI inference chain. So what's going on with serverless? While you are waiting for that response to happen, you still have to pay for the machine that you are allocating while you're not using the CPU. Same happens when you start streaming a response back. And that was something that was making people get a bit away from serverless. Just imagine this. You start getting a lot of requests to your functions, right? You start executing them. Under the traditional serverless, you will start spawning one instance per invocation that you are making. Now, let's say your invocation has, I don't know, an initial 3 milliseconds of execution that basically it's just start the function and then makes a call to your LLM, to OpenAI API, to whatever you are hitting. And then you have to wait for, I don't know, 5, 6, 7. I don't know, maybe you're doing some image generation. You might have 30 seconds waiting. All of that time, you are paying for that. You are paying a flat rate for that, and you are not using the instance that you are paying for. Now, multiply it for the amount of invocations you have, and it will start compounding. You will start generating like these massive bills. That was something that we realized would not scale, that would not make it. And we started seeing like some companies were starting to move back into different approaches, like traditional servers, where you can just have your BPS running and just smash it with requests. And while one request is waiting, another request can take that machine and run, etc. So we came up with Fluid. That Fluid ended up being the best from servers, the best from serverless. You have this reuse of the instances. Now each instance of your traditional serverless work as a server itself that can handle multiple invocations. And at the same time, you have the whole flexibility and scale to infinity and to zero that you have with servers. If you don't have any requests going on, you are not paying for it. That's the counterpoint against servers that you have to be paying for the server all the time. If you have multiple requests coming, multiple invocations coming, you will be able to handle them within the same instance and then scale to the next instance before degradation, which was another problem with servers that you had to provision them. I don't know if you remember back in the days, you will have your server, suddenly you will have a spike, and your server you will have to choose between degrading or provisioning, usually in a slow way. It depends how good were you with DevOps. So that's how Fluid was born. We need a new execution pattern. We need a new execution model for cloud computing that can really fit these new workloads.
Yeah, historically, I mean, for the last few decades, computing was a lot about web application and team trying to shave any millisecond of offloading or execution, and serverless was perfect for that, right? You would pay just for what you consume, and because consumption was very short-lived, you could reduce your bill instead of paying for computing. But as you said, with AI workloads, now slow is better in many ways. It's been proven again and again that if your LLMs are working longer, they will generally return better output. So, Mariano, can you tell us a little bit more about Fluid's secret sauce behind this ability to drastically reduce the cost?
Yeah, I think like as I said before, the secret sauce is the ability of being able to overload one instance with multiple invocations. And then what makes it magic, I will use quotes there, is our load balancer. We have a router and a load balancer there that will take care of not degrading the performance, because that's another problem that you have. You will have now an instance being able to handle multiple invocations, but you do not want to give up on performance. You want to keep the same performance, the same reliability that you had before in the serverless world when you have like a one-to-one instance. In the serverless world, sometimes it was a bit of an overkill having that one-to-one. Now we have this one-to-many, but we need to make sure that that many fits within the invocation in a nice way. I feel like the secret sauce is there. The secret sauce is how do we balance your workload and the ability to compact your workload in as few instances as possible without degrading your performance.
Load balancing is often associated with reliability, and our podcast is a lot about that. Can you share? I know Fluid has a lot of interesting feature built in, but can you share about a few ways that Fluid helps to run workload reliably?
Yeah, I think like the main things we have there is that now we're introducing this function failover by default for our enterprise plans, which means we used to have all what is availability zones failover by default. So if your availability zone is down, you would be automatically failing over to another one within the same region. Now we are also bringing to you the whole region failover.
Mhm.
So now your workload has way less chances to fail. It has to be catastrophic to not have any region up in the planet. So I think like that's one of the big things, and it's also came with the whole idea of dense global compute. We have realized that running stuff on the edge was maybe not the right thing, mostly because we were taking your execution, your compute all out from your data. You will still have the trip to the data. You will have that latency being added anyway. So what we are going for now is this concept of the global dense compute that is basically having less locations, but really smart locations that will always be close to your data. This is something that has been done for a long time by companies like Google, like Meta, like Microsoft. I think Google, someone correct me if I'm wrong, but they have something like 8 main regions in the whole world, and that allows them to have 40 milliseconds of latency max from any place in the globe. So we are going towards that model. We have our core regions and we have all of the mechanisms within those regions. There is also some extra stuff for reliability that we have, like for example, all the pre-warmed functions. Nowadays, when you run a Vercel function, you will to hit a cold start, you will have to be quite unlucky. They happen. There is like they are rare, but they can happen. But now you have no function, no instance, sorry, in flight, so you don't get the same instance getting a new invocation with the whole fluid concurrency model. Then you will have to have no pre-warm function. We have pre-warm functions for your functions most of the times. And then you will have to basically fall into a cold start. And even if you fall into a cold start, it will be quite fast because we have our own control plane that is running on Rust. We also have bytecode caching by default for all of our customers. So things are getting better, things are getting faster. You will have a more reliable latency. Your functions will run, the performance will be reliable for you.
Because the paradigm behind how backend are built and infrastructure is built with Fluid for LLM-powered application versus pure web app, the historic standard one. The paradigm is like almost at the opposite. So do you think there is people should rethink the concept of serverless? Do you think this is industry defining concept that's going to be applied to by other provider or in other area of our tech stack?
Yeah, we invite other providers to write into Fluid, to have their own implementation of Fluid. We think like this is the way that we are pushing the web forward. At the end, that's about it. That's all about making the web win, right? So we think that right now, with the modern web workloads, this is the way to go. There is still space for serverless, there is still space for everything else. This is a stance that we are taking, but yeah, we really think that this is the way to go at the moment.
Right. Yeah, I don't see why. I mean, this is just a win-win for everybody. So I don't. I mean, obviously, like Vercel cannot complain about large bill, but that's obviously not a long-term format that you can do overcharging your customer. Is not something great. So we'll probably see this concept being used by other providers. So Mariano, what's in it for application developers?
Yeah, I think like there are two main things there. The first one is that this helps you to focus on your business, focus on your application, focus on developing your thing, solving your problems. You don't need to be juggling different infrastructures, trying to figure out how to run your stuff more efficiently, because you can rely on Fluid running it in the best way for you. And the second one is maybe something that you need to rethink if you are coming from all your life doing serverless. I know that a lot of people is not, but that's something that happens sometimes. Now you have multiple invocations going through the same instance. What does it mean? It means that if you are, for example, mutating your global state, then your global state will be mutated by all of your invocations, and that can generate some issues. You now need to think about more about servers, and it will work exactly as it works when you run your dev server, when you run next dev. Exactly the same behavior will happen now. You will have a shared global state, yet all of your invocations will be able to mutate. So if you don't want to avoid that, you will need to be more careful on how you scope your variables, how you scope your functions. And if you want to take advantage of having this shared global state, you can also go for it.
Mariano, last question. If a listener want to find you online and get in touch, where can they find you?
Yeah, they can find me on X. My handle is Cocirio, so they can just shoot their DMs there. I'm happy to talk about Fluid, about infrastructure and web in general, and the whole compute journey that brought us here.
Thank you for coming on the podcast. Bye.
Thanks. See you later.